You're getting better? Are you starting to get comfortable? Yeah, good. That's great. Anybody done any programming projects, even small ones that have nothing to do with this class in Python? Yeah, so think about those kinds of things, even simple things like silly stuff like your your digital camera gives you, produces image files with a bunch of names, and you don't like those names. You'd like to change them to something meaningful. It's like a couple of lines of Python. You can change the names of 10,000 files. You can also accidentally delete them all, so be careful with that. But don't be afraid to use it for your own things and for things that might be useful to you. And so now that you are comfortable in Python, many of you anyway, it's time to change the programming language. So it's time to make you uncomfortable again. So one of the things I have to do in this course, which it's not my favorite thing to do, but I need to get you guys prepared for what's coming up next. And learning Python and doing these things in Python is great preparation for what is, for everything. But next semester you're going to switch programming languages. You'll be programming in Java. And so it's helpful to spend a little bit of time prepping you for that before you just get thrown into it. The nice thing about using Python is that we can cover, we have covered all of the material in this course that's required of the curriculum, and more, in fact. And we were able to do it so quickly because we're using a nice, easy language like Python, where there was not a lot to learn about the language. So I don't feel that there's anything really fundamental about Python that I haven't taught you. There's certainly more to learn about it, but it's the kind of stuff that you learn by programming and running across features of the language or quirks of the language that you learn on your own. It's not necessary to have it taught to you by an instructor. And so we're at a stage now where we're proficient with that, and we've learned all of the stuff that the course really has to teach you. And now think of the next couple of weeks as just getting you ready for the next course that's coming up. So you won't have to learn a lot of new computer science concepts. A little bit. We'll come back to algorithms a little bit more once we're comfortable enough with Java. But now it's like the time to take a breather, learn a little bit of Java, and start getting ready for the end of semester push. All right. So how many of you have programmed in Java before? Great. So what do you think of it compared to Python? Yeah?
It's a little more accurate. You have to put more information in.
So more accurate. Another word for that is verbose. So there's a lot more typing to do, typically. What's that? Well, so completely object-oriented, I would disagree with that a little bit. It's possible to program in Java pretty much ignoring every object-oriented feature of the language. That's what the keyword static was created for. And many people do program in Java like that, so it's not completely object-oriented. If you wanted to see completely object-oriented language, you could go look at something like Smalltalk, where you can't do anything without creating objects. Everything is about message passing between objects. But it's got a lot more to it, a lot more structure and stuff. So your next assignment will be written in Java. And that means you'll need some kind of Java environment to work in. Java environments are free. There's many of them available. That's interesting. Okay. And a fairly decent one is you can download the Java SDK. The fairly decent ones are available from Oracle. I don't care if you use the Java 6 SDK or the Java 7 SDK. You may as well use Java 7. It's newer. And just Google it, Java SDK. You'll find the Oracle site, and downloads for all kinds of platforms. There's a Windows installer, there's a Mac OS installer, and a Linux installer, and even Solaris. But I don't think anybody here is using Solaris. Okay, so I recommend going ahead and doing that, installing Java. And if you want, you can use an integrated development environment if there's some integrated development environment that you like. But if you don't want, you can also continue to work at the command line like we've been doing. And so let's do that, and that'll give us a feel for how Java works and what's involved with it. So let's say we'll create a file called test.java. This is going to be just a program that we're going to edit. So your Java programs should finish with a .java extension. And you should pick this name carefully. So in Java, the names of files, and in fact even directory structure, is a lot more important than it is in Python. So pick this thing carefully. So we'll call this one test. And when you create a file called test.java, that is a clue that what's in there is a definition of a class, and the name of that class is test. So here's how you create a class in Java. So a few things. The class keyword here tells us that this thing that's coming up is the name of a class, and then we open a curly brace and put some stuff in and close a curly brace. So everything in between these two curly braces is going to be part of the test class. And this word public here, this tells Java that this class is free to use by anybody who wants to use it. It's not hidden from anybody. Anybody who wants to can use the test class. Okay. So what is the first program you write in a new programming language? Hello World. So do you remember Hello World in Python? Yeah, you say print Hello World. So let's do it in Java. So first thing we have to do is, so in Java, everything has to be inside some class. That's why we've already created a class here even before we wrote any code. So we've made this class called test. And some classes can be what's called runnable. And that means they contain a special method with a special name. And the name of that method is main. And that method takes an argument, which is an array of strings. And so if I try and run this class, what will happen is this main function will get called. But it's a little more specific than that. Main has to be public. It has to be accessible to anyone. It has to be static, which means that you can run it without an object. And it shouldn't return anything, which means that its return type is void. Okay. So this public, static, void, main, string, square braces, args is the beginning of every Java program. So every Java program has to have one of these if you want to run it. The only exception are Java applets, which nobody uses anymore, which have a different starting point. Okay, so this is just, the Python equivalent of this would be something like saying, creating a function called def main or creating a function called main that takes some arguments. That's what this is doing here. And it would be a function that's not inside any class. Okay. Would anybody like to ask me a question about this string of characters yet? So for you Java programmers, this looks familiar, but anybody who's a non-Java programmer, do you want to ask me what any of these words mean? Yeah. What does all of it mean? Okay, so let's put in some comments. Here we make a class called test. So that's what all of this is doing. And inside that class there'll be some things. So that's the equivalent to, Python equivalent would be class test, which inherits from object. That's the sort of equivalent Python statement here. We're defining a class called test. Here, this is the program entry point. If we run this class, this is what executes. And it really has to have this special form. It has to be public, so anybody should be able to run it. It has to be static. Static means it's a function that can run, and it doesn't need an object to run on. It's just a function that you can run in Python. Those are the default kinds of functions. You just create a function, and you can just run it. You don't need to create an object. It's only the ones inside of classes that need an object to run on. Its name is main. That's something that it has inherited from a long tradition of programming languages that start at a function called main, that go back to ALGOL in the 60s, and then to B, to C, to C++, now to D. So there's a whole bunch of these languages, and Java is one of them, that always start at this function called main. And main takes some arguments. The arguments are an array of strings. And we'll talk about this particular notation in a few minutes. Okay, so if I run this program, this is where it's going to start running. So in fact, right now I can run this thing. So we're still working on Hello World, but we haven't got there yet. This thing doesn't do anything yet. So one thing that's different about Java programs than Python programs is that Java programs are compiled. So that means that this input file, test.java, is going to run through something called a compiler, which is going to make a machine-readable version of it. So that compiler is called the Java compiler. So if we look in this directory right now, there's two files, test.java and test.java with a tilde, which is a backup file that my editor is saving. And if I compile test.java using the Java compiler, which is what the C stands for, it compiles. And I look in that directory, and now there's a third file in there called test.class. So this Java compiler takes this thing, which we can read, kind of, and makes it into another format, a binary format, which is designed for computers to read. In fact, it's designed for a specific computer called the Java Virtual Machine to read. Okay. So just running the compiler does not actually run the program. It just makes it translates it into a different form. If you want to run the program, you use Java without the C, and you tell it what the name of the class is that you want it to run on. In this case, I want it to run the test class, and that's what it's going to do now. Now, what's going to happen? Nothing. So it executed the main function in that class. The main function has absolutely no code in it, so it doesn't do anything. Now, we want to print "Hello World." So you Java programmers know how to do that. What do? System.out.println "Hello World." Is that correct? Semicolon. Okay. So remember, I asked you, did you notice any differences between Java and Python? So right now we've written a program which in Python is the equivalent of this. So in Python, that's the entire program that we've just created in Java. So I wasn't kidding when I said it's a bit more wordy. It's a lot more wordy. I mean, even if I strip out all of the comments here, I'm still going to have at least this line, and this line of code in there, all of which are more complicated than this print "Hello World." It's because Python is so clean and simple that we were able to do so much so quickly in Python. In Java, we would take a lot more time getting up to speed, learning and understanding exactly what a static thing is, what this return type is, what void means, whether things should be public or private or not. And even this line here, where we want to print something, this is not at all intuitive. So I should go through it one step at a time to explain it to you. You'll maybe remember it for a little while, and then you'll maybe come back to this video later to remember what it's exactly doing. So Java is like Python in that there are a bunch of built-in classes. So for example, in Python we saw there are built-in classes for sets and lists and dictionaries. So in Java there's a built-in class called system, which represents the system, the operating system, I guess. That system class has a variable inside it called out. Out is an output stream that represents the console that you write to. Okay? So it's really, out represents the part of the terminal here that you can send stuff, you can write stuff to. And out has a method, so that output stream has a method in it called println, which takes a string as an argument, and it prints that string. And now finally, a couple of syntax things. Every statement in Java has to finish with a semicolon. So you can think of semicolon as denoting a new line. So we saw that in Python, the way you denote a new statement or a new line is you use a new line. If you didn't want to use a new line, you could use a semicolon to do the same thing, but in Python, you write a statement, you press enter, and you write another statement. In Java, you have to put a semicolon, and you can put enter or not, depending on whether you want to, but usually you do anyway, and that that tells you that it's time for the next statement. So let's compile this thing. So we compile it with the Java compiler, Javac. That updates this class file since we've changed this thing. And now we can run it by running the class called test with just Java, which is called the Java Runtime Environment or Java Virtual Machine. And there we get hello world. Okay. Any further questions? This is all clear. To the Java programmers, it should be easy. To the non-Java programmers, it looks like voodoo. Yeah.
How would you do things like, so let's say around hello world, if you want to add a quotation mark around
If you want to add quotation marks, like the double quotation marks, like I'm using for the string, or the single quotation marks?
either one.
Okay. So for the singles, there's no problem. Java strings are denoted with double quotes, so you can put single quotes inside them with no difficulty. And we can try that. So then you get hello world printed with little quotes around it. If you want double quotes, you use the same mechanism that we use in Python, which is this backslash followed by the double quote character. So remember in Python, when you want to put special stuff inside of strings, stuff that would be problematic, usually it's just enough to put a backslash in front of it. And the same thing is true in Java. So putting a double quote inside a string is problematic because that sort of would finish the string. Just prefix it with a backslash. So compile it and run it, and now we get hello world with double quotes around it. So it's you can escape special characters inside strings the same way. And if you wanted to do a new line between hello and world, it's the same thing. You can use a backslash n to indicate a new line. So Python inherited most of its backslash escape sequences from older languages like C, and so did Java, so mostly they're the same. Most of the things you would do in Python are also work in Java. This is not true the other way around. Java does not have as many ways of specifying strings as Python does. There's no fancy multi-line strings. There's no triple quotes, and single quotes mean something different in Java. They don't denote strings. Okay, so far, basically the first things to notice are curly braces are really important. They denote blocks of code. In Python, it's just indentation that does that. And all of these statements have to finish with a semicolon. So if I wanted to have another statement in here, so let me get rid of that. And if you forget a semicolon, this is what will happen. You'll get an error that's actually pretty good. Tells you there's a semicolon expected there. And even points a little caret pointing at the place that the semicolon should go. Now, that's an error from the Java compiler. So at this point, if you run the Java compiler and you get an error like this, then it has not created a class file for you. You can't run your program yet. Okay. So Java has all the same math, or most of the same math operators that Python does. And it has variables like Python. The major difference between Java's variables and Python's variables is that every variable in Java, in fact everything in Java, has a specific type. So different types that we have available are char, which is a single character. We have short, which is an integer, and it cannot be outside the range something like roughly minus 32,000 up to positive 32,000. We have int, so this is, for those who know about bits, this is a 16-bit integer. We have int, which is an integer, and it has to be roughly in the range between 2 to minus 2 billion up to positive 2 billion. So int is the most common sort of integer you'll use. Its range is big enough that usually you don't run into to problems. If you need a really big integer, you can use a long with a much bigger range. The range is actually something like minus 2 to the power 63 up to 2 to the power 63. And float, this is a floating point number. This is like Python's float. And double, which is a more accurate floating point number. This is also like Python's float. Boolean, which is either true or false. And well, I don't want to talk about strings right now. Well, I'll say string, the character string. So, so these are the basic types that are available to you in Java, and then there's another type beyond this, which is I'll call it an object reference, which we'll discuss, I don't know, at some point. Okay, so for example, so how do you use these things? For example, I can say character C, and so that says I have a variable called C. So this does declare a variable called C that is a character. Okay. And I can assign something to C. What can I assign to C? I can assign characters. So remember I said you don't specify strings using single quotes in Java, only double quotes. Single quotes are used for characters, so individual characters. So that's what that looks like. Maybe more interesting than characters, we don't use them that frequently, is integers. So here let me specify two integers, x and y. And let me say x equals 42. 42, y equals 99, and let's say create another integer z, and we'll say z is equal to x plus y. I'm not sure if this conversion happens automatically. Let's see. So this tells me there's an error in this program. The error is that there's a semicolon missing after this line. So switching back and forth between Python and Java, as I'm doing right now because I'm teaching a course both in Python and in Java, becomes immensely frustrating because of these slight differences. You keep forgetting semicolons in Java. You keep putting in semicolons where they're not needed in Python. So so there's another part of our program. We declared two variables, x and y. We said that they're integers. We said x is equal to 42, y is equal to 99, and then we created another variable called z, added, whose value is x plus y, and then we print z, so 141. Okay, is that clear? No. So the answer is no. If you have a little piece of code that you want to test, you're not sure what's going to happen with it, so in Python all you do is you fire up Python and you type in the code and see what it does. In Java you create a class, so you create a new file, create a class. Inside that file you create a main function, you put in that little piece of code that you want to test, you compile the class, and then you run the class, and then you know what the code does. And you better somewhere in there also print out whatever it is it was supposed to do, because by default there's nothing printed out. So it's not at all like what happens in what you can do in Python. It's a much more structured process, let's say. Okay, so there we are. We know how to do arithmetic of integers. Now let's try something perhaps a little bit different, or let's do something a little bit strange. Let's do 99 times a million. So now we get 99 million and 42. Okay. So let's take that thing and multiply it by 500,000. Not quite big enough, so what are we at? So 522 million. So is that right? So 99 million and 42 times times 500,000. Is that, what's this? 522 million? Doesn't seem right, does it? I mean, there should be a lot more zeros there. So it seems Java can't do arithmetic correctly. Does anybody know what the problem is? let's see if we can multiply it by 50,000. Then we get a negative number. What if we don't ask so much and only multiply it by 5,000? Then we're back to a positive number, but still doesn't seem to have enough zeros. I mean, there should be at least 3 zeros tacked onto the end of this thing, and this one is not really big enough. So, do any of you Java programmers know why this is giving incorrect answers? Yeah. Yeah. So, I told you that an int is an integer, and it has to be somewhere in the range minus 2 billion to 2 billion, roughly. It's in fact, it's a little, the range is a little bit bigger than that. It's actually something like minus 2 to the 32 up to 2 to the 32, and that's off by 1, but don't worry about that. And it's not 32, only 31. So 2 to the power 31 is somewhere a little bit bigger than 2 billion. And if you do a calculation which gives you a result that's bigger than that, then you get garbage. When you do calculations with integers, usually it's fine, unless you get numbers that are too big, and then all you get back is garbage. Okay. So one thing you have to be aware of is this thing. This is called an integer overflow. If you do a calculation whose result is more than 2 billion or less than minus 2 billion, you're looking for trouble. And it's not just if the final result of the calculation is like that, but if anywhere in the middle of the calculation you get a big number, then you're out of luck too. So to see that, we could say, for example, what did we say? So the problem here was this multiplying by 50,000. So you might say, okay, well, let's fix that. You know, maybe we could get rid of that problem by also dividing by 50,000. But no, you still get negative numbers. So the fact that this thing overflowed halfway through the calculation means that the whole thing is now garbage. You can't use it. You can't use it anymore. Okay. Another thing to look out for is this. X equals 3, y equals 2. We've had a bit of exposure to this. So if x is 3 and y is 2, what's x divided by y? So in newer versions of Python, or Python with the new division semantics enabled, 3 divided by 2 gives you 1.5. In Java, it gives you 1. So this is, I should look out, division of 2 integers always produces an integer. So it's like the // operator in Python that does integer division without any remainders. Now, if you didn't want that to be the case, well, rather than declare x and y to be integers, you could declare them to be floats. In that case, you get the correct answer, 1.5. So integers really are that, just for integers. If you do arithmetic that's using integers, you're going to get integers back. And floats, if you do arithmetic with floats, you'll get floats back. There's not this somehow these two kinds of arithmetic or different division operators. It really depends what kind of data you're using. Yeah.
What if they use x as a float, y as a...
Let's see. If you use x as a float, y as an integer, anybody guess what will happen? Yep. Compile, test. It works. If you did it the other way around, it wouldn't? Like this, you mean? Let's see. So it works actually as long as one of them is a float. So the rule that Java uses is floats are somehow more accurate for, well, for things like division. They're certainly more accurate when you do division. They don't just throw away the remainder. And so before doing an operation like this, if it's one argument is an integer and the other argument is a float, it'll take that integer and turn it into a float and then do the floating point operation. Okay. So the result of this division here, even though only one argument is a float, is done as a floating point, a float operation by first converting the integer to a float. Now, here's something you have to look out for. So now rather than print it, I would like to say, let's save this value x divided by y in this integer z here. So do you know what that does? I can print z if you like. You know what this does?
We'll throw in here.
Yeah. So it throws an error, and this is one of the things that Java is good at. And in fact, we're starting to see that Java is a lot more wordy than Python, and you have to specify a lot more things. Even to write the simplest programs, you have to write a lot of stuff. And so you might be wondering, okay, well, what do you get in return for all that extra work? Well, what you get is a lot more careful checking of things from the compiler at the time it compiles. And here it actually throws an error, and it's telling you, look, you're doing this operation here, which is going to give you a floating point number, and you're trying to store that in an integer. And, well, that means you're going to lose something when you do this. So it tells you, look, there's a possible loss of precision, and in fact, it won't even let you do it. So it tells you, look, you needed an int over here, you gave it a float, and that's just not allowed. If you insist on doing this, then you can take this expression and convert it to an int, and it looks like that. So you use this funny notation. You write int surrounded by brackets, and whatever comes after that will be converted to an int before it's assigned to z. And really, then it's happy to do it, but it will throw away that 0.5 that was part of it. And really all this is doing is telling the compiler, look, I know that this is a float, and I'm assigning it to an integer, and that might lead to a loss of precision, but I'm aware of that, and I'm willing to do it anyway, so don't bother me about it. That's all that this little conversion does. So, so the note here is that the compiler will not convert float to int by itself. So you have to specify it, and the programming language terminology for that is no It will not do implicit conversion of float to int. Okay. Questions? Yep.
Is there a mod type operation?
Yep. So here's a list of the things that. So list of Java's numeric operators. I'm not sure if this will be completely exhaustive. So there's addition, subtraction, multiplication, division. What else do you do with numbers? You compare them all kinds of different ways. Equality. What else do you do with numbers? Exponent. There's no exponentiation. That's not an operator in Java. So it's something that's in Python but not in Java. Negation. So call that unary minus. Anything I'm missing? The exclamation mark is usually reserved for Boolean values. So that's the not operator. So yeah. So these things here take two numbers as arguments, and then they give you a Boolean value, which you can then negate. Oh yeah, not equal to. That's that one there. But you've seen all these. So all of these things that are also in Python are supported for Java's numbers. And if you mix float and int, then the ints get converted to floats before doing the operation. Okay. Oh, mod, yeah, that was the original question. The mod operator is supported for integers. And of course, parentheses as well. So, numeric expressions look the same pretty much in Java as they do in Python, except for exponentiation. Java has a class called math, so about exponentiation. So Google is your friend again, just like it was when we were learning about Python. Go to Google, Java, some class that you're interested in or something you would like to do. In this case, I know about a math class. I want to find it. And the place to find decent documentation about the classes in Java is from Oracle. They're the people who maintain Java these days, at least the reference versions. So there's this class called math, which has all of these methods that we used to import from math in Python. So absolute values, cosines, sines, arcsines, all kinds of things, ceilings, things for getting exponents, logarithms, max, and I think there's a POW in there. So POW returns the value of the first argument raised to the value of the second argument. So if I wanted, for example, let's say float q equals math.pow 2 to the 4. So what's the value of q then? 2 to the power 4 is, so this is equivalent to Python's 2 to the power 4. Now, one thing to notice, if you read the documentation for this function, it takes a double, and it returns a double. So let's run it. Required float found double. So it gives us an error. Now, why is it giving us an error? Well, I said Q is the same kind of error we've seen before, possible loss of precision. Q is a float, and math.pow returns a double. And if you go back and look at the list of types, I said that there's float, which is a floating point number like Python's, and there's double, which is a more accurate kind of floating point number. And so it's telling me this function is returning a double, a really accurate floating point number, and I'm assigning it to this float thing, which is not so accurate, so you might lose something if you do that. Yep.
And we have to import math class.
Math comes for free, I think.
Okay.
So let's just fix this error and double check that. Yeah, so math is a freebie for us. And so actually, everything in the java.lang package, I think, is you don't have to import it. So math is in there. We'll for those of you who don't know what that means, don't worry about it for now. Okay, so you can use any of these math library functions. That's where they're all hiding. Basically, the things that you would do in Python by importing some function from the math module, you can find it in Java's math class. Okay. Now, one of the things we used a lot in Python were lists. And in Python, I kept all of the Python documentation calls these things lists, but I kept alternating between arrays and lists as the word that I use for these things. In Java, you have arrays, which are a little bit, well, they're a lot like Python's lists. The main difference is the size of an array is a fixed thing. So, for example, let's make an array consisting of 3 ints. So I use the int keyword. The thing that I'm going to make is something to do with ints. I put square braces, and this says I'm about to declare a variable, or I'm about to declare something that is of type array of ints. So let's call it A, and we fill it in with 1, 2, 3. So this creates an array A that has the values 1, 2, 3 in it. And Java has for loops. The notation for them is a slightly, well, there's 2 kinds of for loops in Java. The one that's similar to Python's for loops look like this. We would say for int x, so in A. So this is like, in Python, this would be for x in A. That's what that would look like. And so for each value in A, assign it to the variable x, and then execute the code that's in the following block. So we'll just print it. No, we already have a variable called x up here, so let's just change the name of that to q. No, we already have a q. P. So there it prints the values in that array, A, 1, 2, 3. Okay, so question about that? Yep.
Does everything in an array have to be the same type?
Does everything in an array have to be the same type? Yes. Everything in an array has to be the same type. So it's either an array of ints, or it's an array of doubles, or it's an array of floats, or it's an array of strings, or it's an array of objects. And so actually, if we go back up to this top of this function, we saw that when we declared main, we actually used this notation. We said main takes an argument that's called args. We could call it whatever we wanted, but the type of that argument is a string array. Okay. So actually, if we want, we can go and look at what those args are. We can say for string s in args, system.out.println s. This is a for each statement for each value p in a. So it's the, or each string s in, for each integer p that's stored in a, or for each string s that's stored in args. So let's take a look at it and see what's in there. So looks like there's nothing in args. Anybody know how to get something in args? Yeah. So somewhere way back early on in Python, if you actually did the tutorial exercises, you learned that there's a way to take arguments that are given on the command line and use them inside your program. And the same thing is true in Java. The same thing is true for almost every decent programming language. So while running my program, I can pass it some arguments. So for example, argument 1, argument 2, and arg3. And if I do that, well then that's actually what populates that array. So the first element is the first argument, argument 1, the second element is the second argument, and the third element is the third argument. Okay, so you have these arrays, you can iterate over them. Now, you can specify arrays like this by using curly braces and listing their elements out. But that's kind of limiting because, well, what if I need an array of size 1 million? I don't want to have to put list out a million elements in my code. So there's a second way to do arrays, which is to say A equals new int and whatever size of array you want. So I don't know, let's do 20 of them. So this creates a new array that holds 20 values. And just for fun, let's look at those values to see what they are. Anybody want to guess what they are? They're all zeros. Okay. So, in fact, this is true for any variable that you create or any array that you create. There's always a default value assigned to it. And the default value depends on the type, but the golden rule is the type is some version of 0. So for an int, it's the integer 0. For a float, it's the float 0.0. For a double, it's the double 0.0. For a Boolean value, it's false. And for a string, it's actually null. which is a special kind of thing, and an object reference will also be null. So everything gets a value. For example, even at this line of code here, if I print x, that's going to print 0, even though I've never assigned any value to x. And I can count on that. Okay. All right. So any questions about that so far? Is there anything you don't know how to do yet in Java? For loop with numbers. So for example, what if I wanted to do something like, you know, let's do Python's something like a equals range 20. So that creates an array of 20 elements, but those elements are 0, 1, 2, 3, 4, 5, all the way up to 20. So, so this creates the array, this piece of code here, but we know now that that array contains all zeros, and we want it to contain 0, 1, 2, 3, 4, 5, all the way up to 20. So Python, or not Python, Java has a second kind of for loop. And if you haven't seen it before, it can look a little bit strange. It's a 3-part for loop. It looks like this. So you use the keyword for, and then you're going to have a pair of parentheses, and inside of there you're going to put 3 statements. The first statement is the setup for the loop. Before anything executes, the setup happens. So what I would like to do in the setup is declare a new variable I and set it equal to 0. So this setting to 0 is actually optional because by default it would be 0, but this at least makes it explicit. The second part of the for loop tells us whether or not the loop should continue for another iteration. So if I want to count from 0 to 19, then how would I, so I want I to take on the values 0, 1, 2, 3, 4, 5, all the way up to 19. So I want to write something in here that's true as long as I is less than or equal to 19. So I'll say, let's go for I all the way up to 20, less than 20. So if I is bigger than or equal to 20, then this is going to be false, and this loop should not continue. Otherwise, it should continue. And then the third part is what to do after each iteration of the loop. And in this case, what we want to do is increase the value of I by 1. Okay. So for now, we'll just print I, just to see that this does what we think it does. That's interesting. It doesn't like this uninitialized variable, but we'll leave that for now. So this last little bit of the printout starts at 0 and goes all the way up to 19, which is what this 3-part for loop was supposed to do. So indeed, this does count the way it's supposed to, and if we wanted to simulate creating exactly this statement in Python, then we would say a at I equals I. So these lines of code here, they are the same thing as saying a equals a range of 20 in Python. Okay. So these for loops can look confusing to new people, and maybe the easiest way to understand them is by replacing them, or by showing how they translate to something that you are familiar with, and that's a while loop. So that for loop above is exactly the same thing as this while loop. So you start by setting I equal to 0. You say while I is less than 20, execute some code, and then increase the value of I by 1. So in this case, the code that we execute is A at I equals 1. Right? So this is part 1 of the for loop. This condition is part 2. And this last step is part 3. And this recipe here is this type of for loop for I equals 0, I is less than 20, I plus equals 1. That's a really common way to iterate over arrays. More generally, it would be you do this for the length of A. So you can ask an array what its length is, and the way you do that is you just say A dot length. So those are the same two pieces of equivalent pieces of code. All right, that brings us to one other thing. If you see a for loop where a Java programmer who knows what they're doing is doing iteration like this, well, for those of you who are Java programmers, what looks weird about this for loop that you would never see a Java programmer do? Yeah. Plus equals 1. So I plus equals 1, which means the same thing as I equals I plus 1. So I plus equals 1 is already a shorthand for I equals I plus 1. But a long time ago, people decided that, well, I plus equals 1 is a great shorthand, but it's still too long. We want an even shorter way to write this same thing. And you can say I plus plus. That's the same as I plus equals 1. For our purposes right now, there's a slightly different thing, issue with that, but for what we need to know about it right now, I plus equals 1, you could replace that with I plus plus. Okay. Would anybody like to ask me any questions? Yeah.
How do you print a graph? Actually print out the print
How do we do nicely formatted printing? You know, like the percent stuff. I believe there's a printf. There's some printf formatting in Java, but it's not so simple. Formatting numeric print output in Java. Yeah. So there's a thing called system.out.format that kind of does what you want. Kind of does printf formatting. So let's try it. I've never used it before. System.out.format. Anybody used this before? Any of you Java programmers? Yeah. Yeah. So it it works like our print statements that we're used to, sort of, or our percentage formatting that we're used to. Says the value of I is %d, and the format version does not automatically add a new line at the end, so if you wanted a new line, you'd have to put a new line there. So the value of I is 20, and if we had something else in there, and what was another variable we had? Q equals %f. I think Q is a float. Yep. So we have a %d and a %f, and we pass I and Q as arguments. And indeed, the %d shows up as we want, and the Q shows up as a floating point. And all of the usual modifiers should also work. So if I only want 2 decimal places for Q, then using the %.2 will do that. Okay. Maybe one thing that you might want to know is, so we know how to print stuff to the output, but at least for some basic applications that we might start with, we might want to read stuff from the user. So any of you Java programmers know how to do that? Yeah. Scanner on what? So if we print a system.out, what do you think we read from? System.in. So in the system class, there's a variable called in, which is some kind of input stream. Unfortunately, it's a useless kind of input stream that's not much good for doing anything with by itself. So you actually create a new thing called a scanner. And so I'm going to create a scanner. So I need a variable for it. Let's call it SC. And it's going to be a new scanner, which is used for scanning system.in. So here we're seeing a few things for the first time. So scanner is one of the built-in classes in Java. It is we can Google it and see what it can do. Well, you see that the first example use of scanner is to create a new scanner on system.in, and we can use a scanner to read things. And probably the most useful way to use it would be to do something like this. Some string s equals sc.nextLine. So we ask it for its next line. So we've created this scanner, and we'll say, give me your next line. And then we can well, if we want, we can format, for example. We can practice using that. Let's call this string st. So we'll create this scanner, and then we'll read one line from it and see how that works. Okay, can't find symbol. So now we get into imports. Just like in Python, there's this huge library of stuff that's available to us, but sometimes we have to tell Java that there's certain parts of the library we want. So by default, it's not all there. We have to ask for certain parts of it. This scanner class is one that's not there by default. It's in a package called java.util, and its name is scanner. So if we want to use it, we go up to the top of our file, and we say import java.util.scanner. Now we get to use it, and so now the program is sitting, the scanner is scanning for a new line, so it's just sitting there waiting for me to enter some text. Okay, so I'll enter some text, and then this text gets stored in a string. Right, so here's where we got that new line. It got stored in this string st, and then we printed out that string inside of a format statement. And we forgot to put a new line at the end, which is why the prompt appears immediately after that. Okay. Any questions? Yeah.
Is there a way to import Unicode format?
By default, Java strings handle Unicode with no difficulties, I believe. I think that was one of the points of Java when it was created 17 years ago. Other questions? Comparisons? Sure, they're similar to what we're used to. So, for example, we can say things like, well, scanners can do a lot of things. So let's just do a quick example. X equals sc dot next int. I think a scanner could get us. Yeah. And then y equals sc dot next int. If x is less than y, then we can say system.out.println x is less than y. Otherwise, so a lot of these things most constructs are similar to what you have in Python, except that there's curly braces around all blocks of code rather than just indentation. And here we'll say x is not less than y. Okay. So we'll scan an integer x, we'll scan an integer y, and if x is less than y, we'll print one thing, otherwise we'll print another thing. So we compile it. Test it, so some text. Okay, so x equals 23, y equals 45, x is less than y. We can try that again. X equals 54, y equals 22, x is not less than y. So if statements work the same way as they do in Python, but there's no else if. If you want to do something like an else if, you do something like this. If x is bigger than y, and then finally finish with an else. So this is the equivalent in Java of Python's if, else if statements. You can chain any number of these else ifs to get the same effect. So let's try. X is less than y. X is greater than y. And finally, x equals y. So we'll leave it at there for today. That's your basic introduction to Java.
If Java doesn't import the Unicode, is it possible to just import it with an import statement, or what else would you have to do?
Well, I think
Because I tried using it and it didn't work. I got a question mark.
really.
For what I tried
So
using.
you mean Unicode source files or Unicode?
Like if you want to print something that's in Unicode format, would you go system.out.format to print that? Or?
Yeah, I don't know. I've never done much with Unicode, but yeah, I mean, if you Google it, there's some recipe here. So, for example, this creates a string with some weird Unicode characters in it. You want it to be printed that way, and if you want to, yeah, you can convert it between different Unicode locales. So. So I guess you take whatever messy string you have, you convert it to UTF-8, and then it's ready for printing. Should be ready for printing on whatever Canadian terminal you're using. But if someone else is using a different, if someone else is using a terminal that has a different encoding, then you'd want to convert to that encoding.
Okay.
But UTF-8 is most common for most of the English-speaking world, I guess. Yeah, so we won't be doing Unicode stuff in this class.
Yeah, just personal stuff.
Yeah.
I need to ask you a question concerning the assignment. In my previous song, I think Paul was going to give a correct analysis, because what I did was, if you give a number, first it checks if the number you're giving it is a valid number. So when you give it a number, it sorts the array and gets the last three elements, the largest elements, adds it up. And if the number you're giving it is larger, then it returns none immediately. And then after that, if it's valid, then it goes into this recursive call. And then in my recursive call, I had another condition that checked if it picks an element from the array and the element is less than x, then it can append it to the array of three numbers that it's going to check. And if the sum of the three numbers that's the array, because how it works is it starts with an empty array, and every time it appends a value into it, then it calls the recursive call again. So the base case is when the length of the array is 2, so that I could check the sum of the items in the array and check if the difference from the number you gave it is in the array.
Yeah, okay.
So in this final place, I now added this last one because I was trying to make the code faster. So what this one did was, if it checks a value from the array and it checks if it's greater or equal to the number you gave it divided by 3, just so it could have a way to start. It cut down the time by like a really reasonable amount, but I don't know how to put
If
this
it
into my
checks if the number in the array is bigger than or equal to.
the number you gave it divided by 3.
Yeah, why?
Okay, let me give an example.
Why
If-
should that be a good check?
Okay.
And why is that valid?
Okay, because if you have 2,999,4, that's the largest you could get from an array of 10,000. Array of range 10,000. Because 999.
Okay, but this should work for arrays of any numbers, though.
Yeah, it works for arrays of any numbers.
Even
'cause
negative numbers.
Even negative numbers.
Okay.
So if you divide it by 3,
So one of the numbers has to be bigger than or equal to that
two
divided
of
by
the
3.
numbers, if one of the numbers is bigger than the other number,
Yeah.
either two of the other numbers will be less or two of the other numbers will be bigger.
Yeah, okay.
So when I tried it with it works pretty fast for.
Well, you can have, yeah, so, yeah, so what you know is one of the 3 numbers is bigger than x divided by 3.
Yes, that's the basis I'm using to work on the algorithm. So if you have triple,
So you're only trying triples that are bigger than or equal to x divided by 3.
something like that. If it can find one that is bigger or equal to, even if it's 1, which probably you'll always find one which is bigger or equal to.
Well, if there's no numbers bigger than or equal to x divided by 3, then there's no way to make that sum.
There's no way to make the sum.
Yeah.
So, 2,999,4, and it computes it in less than a second.
Yeah, but that's so you're implementing some heuristics here that will help in a lot of the cases. But for example, if you take an array that contains, one. So let's say x is 3,000, and the array contains something like 1,001, 1,002, up to, I don't know, 1,000 and n, so on, 1,050, I don't know, 1,001, let's say. So that's 100 elements, and it contains some other stuff after that. I don't know, a bunch of random numbers between that are less than 1,000. So another 200 numbers, and maybe they're all less than 1,000. So then there's still, for that first number that you're picking, there's still 100 choices for that number, right?
Yeah.
And then it's going to try every pair of these guys to see if they can fill in the gap.
It's going to pick 2 from here and find 1 from there. If it can find 2 from here, it's going to pick 2 from here. If it doesn't, then it's going to pick only 1.
Well, what do you mean if it can find 2 from here?
Because if you divide 3,000 by 3, you have 1,000. And let's say we're looking for a number like 1,050.
Yeah.
So if you're looking for 1,050.
But let's say you're looking for 3,000.
Okay, if you're looking for 3,000, okay, yeah, 3,000. Divide 3,000 by 3, that's 1,000.
Yeah.
So it looks for any of these numbers that are greater than 1,000, which can be this one, and it picks this one.
Yeah.
When it picks it, it calls the recursive call again.
Yeah.
And the recursive call will probably pick this one as the second one.
Yeah.
It adds the 2 together.
So the recursive call recurses on everything except that number. Is that right?
Everything except...
So it recurses on all these numbers?
Yes, except this number now.
Okay.
And now it picks this one as the second one.
Yeah.
It adds it to the array. So what the array has is now of length 2, and it goes to the base case. It adds this 2 together,
Yeah.
finds the difference from this.
Yeah.
If the difference is contained in this, then it returns true, and then it returns the index.
Okay. So, but, what if there was no such number? So these two numbers together are 2003, which means 997 would have to be a number. So what if it's not there?
If it's not there, then it undoes the last one
And moves on to,
and
the,
moves
next
on to the
one.
next.
So the next one would be like
1003. Yeah.
Okay. So it's going to check 1,001, and eventually, if none of those work out, it's going to have to try the 1,001 versus every other
Every
number.
other number.
And then what happens next?
If if it is tried with 1001 as the first one,
Yeah.
and nothing goes, then it comes to this second one.
Yeah.
And does.
So then it's going to try that, and
Yeah.
it's going to try that with every other
Yeah,
number.
every other number.
And if none of those work,
Do the same thing. Try
Okay.
like this.
so it's going to try, if there's 100 numbers here, it's going to try all pairs, which is, well, it's 100 times 99 over 2. So, which is, n equals 100. This is about n squared over 2. And how does it try one of these pairs?
How does it try one of
Yeah,
them?
so when I take two of these numbers, how, what's the test after that?
It's going to sum these two numbers.
Look at the
and-
difference
and
from
look
x.
at the difference from x and check if it's contained in any of these in the numbers that are left.
And
in
how
the
does it
array.
check that?
The remaining numbers that I have from every array that's been passed on,
Mhm.
I convert it into a set,
Yeah.
and then I check if the number is in the set of the array. If it is, then it returns it.
Now, do you convert it to a set? Well, do you convert it to a set each time?
Each time, only at the base case, because I have two instances of the actual array that was passed, because I didn't want to change the order of the index.
That's fine.
So it checks with the array that you keep on, because every time you pass an array, you're going to remove this other number. So that array is kind of, it's a mutable array. So it has probably been changed a lot of times. So what it has left is just the other numbers that don't include those two numbers that it has that you're looking at. And then it converts it into a set, and then it checks if it's
But that means it's converting it into a set for each pair of these numbers that you're checking.
yes.
Okay, so that's not good. Because now if you look at this thing, what have you got? So already you're going to check, in this case, if n is 100, so this is the n here, you're going to check n squared pairs. And for each pair, you're taking a big array and you're converting it into a set. And that takes time that's proportional to n. So you're going to get something like n cubed. Now, you're not seeing that because for the inputs that you're testing, this idea of taking the bigger, starting with a number that's bigger than a third is helpful. But if you give it a set like this, then you're going to run into problems, especially if you give it a set that has like maybe the numbers in it are 1,000,000 up to 1,010,000, and the target value is 3 million, and then there's a bunch of other numbers in there that just never work out. So you'll try out all 10,000 pairs here, and you'll convert the rest of this stuff into a set.
Yeah, it only converts it into a set when it's about to check if the last number is in the array.
Yeah. Well, but that's, it's going to do that for every
time you have
every pair, right?
Yeah.
Yeah. So, right. So the thing that's killing you. So you'll never really do better than O of n squared for this problem, in the worst case. So you can try things like starting with specific numbers, and maybe you'll get lucky. But in the worst case, you'll never do better than n squared. But the thing that's killing you here is that you keep making a new set out of this each time you get a new pair. When in fact, you could probably do it a little bit more easily, because really what you've got is, when I test 1001 and 1002, you have a set that has these things in it, the rest of them. So you can, if you want it, right, now when it's time to test, to change this, well, I'll go to, so you've already checked 1001 and 1002, so you never have to worry about 1,000. If there is a solution that has both of these, then you will have found it by now.
Yeah.
Okay. So when you move on to 1003, as your two numbers, then all you really have to do is take 1003 out of your set that you already made. 1003 out of this set.
Okay, so you should have a set already defined.
Yeah, so you can define one set that has everything.
Oh, okay.
And what you can do is, well, it's not the best strategy, but an idea is to then, if you've already got two numbers in your hand, you just take them out of the set and then look for the target value.
Okay. Instead of making a set every time, then if it doesn't work, you can always add these numbers back into the set.
Yeah.
Okay.
Yeah. But be careful because you also want this to work for arrays that have the same number in them more than once.
But it said distinct numbers.
Oh, does it say distinct?
Yeah, the assignment said distinct.
Okay.
numbers.
If the assignment says distinct, then you're okay. I didn't think it said that, but.
Is the lowest computation effort that it takes to solve this lower
No, you can do n squared.
That's the worst case.
Yeah, so n cubed is what you get if you do the triple for loop that tries all three pairs.
I'm using the iter tools combination to create a combo of two elements, tuples, and that would be n squared.
Yeah.
And then I'm also looping through that entire combination to match it with a remainder of.
But what are you doing the matching with the remainder? How are you doing that?
Not remainder,
The
difference.
You add those two together and there's a difference with the target. And then how are you looking for that?
I'm searching through it in a set of all the.
So that's fast. So that should give you n squared.
N squared.
Yeah, because you're trying n squared combinations. For each combination, you're looking into a set to see if one particular value is there. And you're using, the code you should be using is x in s for this value x that you computed that's the difference between the two things. So let's see the wording of this thing though.
Write a function, triple sum index that takes an array A and determines if there are three distinct elements in the array of the sum is that.
Yeah, okay, so that's a badly worded question, so you can do as you see fit. So I meant three distinct indices, but whatever. Just explain it in your code. If it doesn't work for, so I meant to be able to accept solutions where you have an array that contains, for example, 1,000, 1,000, 1,000. But that's not clear from the wording of the question. So if you can't, if your solution doesn't find those things, then it's okay too.
Okay. Because for my own, what do you call it? My algorithm. If I was to draw a graph, because that was what I was testing.
Yeah.
If I was to draw a graph, depending on the number you give it, the graph is something like that with respect to the time.
Yeah.
Something like this. Depending on if the number that you give it is at the how do I put it?
At the extremes.
Yeah. At
Yeah.
the extremes.
So you typically, when we do algorithm analysis, the basic kind, we're interested in what happens in the worst case. And so here is an example where, for example, your algorithm will end up doing, if you just go to building the set at each phase, will end up doing n squared things. If you switch to not building the set at each phase, but actually just adding and moving a thing at each step, then it'll do n squared in the worst case, which is about the best you can do. So the hard instances of this problem are when you have numbers that are all a bunch of numbers that are close to x divided by 3,
Yeah.
and then some other ones that none of them just seem to quite fit together the right way.
Yeah, that's the thing. It's super fast.
That's
It's for large
coming up.
numbers.
I know this is big and
This?
yeah,
No, this is a big running time.
big right now.
Big. Yeah.
Why? Like that.
Well, try it for n equals 100. Or even n equals 50, I think that'd be a problem. Now, if you remember, we talked about Fibonacci in class,
Yeah.
and we saw that when you implement it recursively, right, so the normal Fibonacci has something like fib of 100 is equal to some number with 26 digits. So it's a huge number. And then we saw that if you implement it recursively, well, how does that look? Well, to compute fib of 100, you end up computing fib of 99, and you end up computing fib of 98. And that computes 98 and 97. And this goes on, this one needs 97, 96. And ultimately, nothing ever stops until you get down to the bottom, where you have all these ones. And so, and then you can think of really what this whole thing is doing is just adding up all of these ones, which means that it's counting, starting at 0, it's counting by one step at a time all the way up to this number that has 26 digits. That takes forever. I mean, this is doing, has some value that it's pre-computed, and then it adds 1, and then it adds another 1, and it adds another 1, until it gets all the way up to this thing. So that will be very slow.
Okay. Okay, I'll work on it.
I mean, you can test it for, try it for n equals 50, and you'll see that that either takes forever or, at least a long time to do. Yep. Yeah.
Is this job more difficult than Python?
Is it more difficult? There's a lot more to write, and it's a little bit more strict about things. But at least for this course, the problems we'll be solving are simpler. We're not simpler, but they'll be going back to like as simple as the first kinds of things we were doing in Python. So it'll be more of now just learning this language and learning how to take solutions to problems that we know how to do in Python and writing them in Java. So it's like, I don't know. It's, in Python we've worked our way up to writing, really good literature, and now it's like we're learning a new language and we're going back to just learning how to express simple sentences. Yeah, it can be difficult, but
Find like notes on Java, maybe before we get started next semester.
yeah, you may want to brush up on it. There are some good, just Google for Java tutorials. There are a few good ones online. Maybe I'll link the one from the web page as well.
Thank you.
Yep.
Thank you.